Let's cover multi-step inequalities. First, I want to go over two review problems. X plus 3 is greater than 8. Well, we need to know how to solve inequalities using one step. So, if we have plus 3, in order to move that to the right, we want to subtract 3. 3 minus 3 cancels out, and we are left with x is greater than 5. Now, if we quickly graph, because it's greater than, we will have an open circle. Because my point faces to the right, my arrow point should face to the right. That means any solution greater than 5, but not including 5, is a solution. Let's look at number 2. It's a two-step inequality for review. In order to get this 3 to the other side, we have to subtract it. What you do to one side, you have to do to the other. 3 minus 3 cancels out, and we're left with negative x is greater than or equal to negative 8 minus 3 is negative 11. But my x is negative, and we want it to be positive. So we have one more step. We're going to divide by negative 1 on both sides. So my x becomes positive, and I have negative 11 divided by negative 1, which is 11. And my golden rule of solving inequalities is I have to flip my inequality sign. Why? Because at this last step, when I divided by negative 1, I divided by a negative, so I flip my sign. So whenever you divide or multiply, on the very last step, that last step should always be when you're isolating the variable. So if you divide or multiply by a negative, meaning the denominator is negative, then you flip your inequality sign to keep your statement true. So now I'm going to graph this. So if 11's over here, as you can see, my point faces left. So I'm going to have a closed circle over 11 because it's less than or equal to, so this is an included solution. Point it to the left. As you can see, my dots face the same way. So now let's look at multi-step inequalities. Multi-step inequalities means we're going to use the same steps from our multi-step equations, only now we have an inequality sign, and we have to make sure that we watch out for our inequality signs on the last step. Just a refresher, less than, equal, or greater than, use an open circle. Less than or equal to, greater than or equal to, use a closed circle. Why? Because of this equal to. When you shade it in, what you're saying is that this solution can be plugged in for x and the inequality will remain true. Means it's a solution. So when we graph, we have an open circle facing left, or we have an open circle facing right. See how they face the same direction? That's how you know you've graphed correctly. So now we're going to solve. We have a problem. 4x plus 3 is greater than negative 24. Our first step is to distribute as always. So 4x plus 12 is greater than negative 24. As you can see, we need to move this number so that it's on this side with this number. Let's combine those. We're going to subtract 12 over here so that this disappears. What we do to one side, we have to do the same thing to the other side. We're left with 4x is greater than negative 24 minus or plus a negative 12 gets us negative 36. We want to isolate our variable. We're going to divide by a positive 4, which means our inequality symbol stays the same. X is isolated, and negative 36 divided by 4 is negative 9. When I graph that, I'm doing the shorthand version for graphing. I'm going to have an open circle over the negative 9, and my point will face to the right. As you can see, my point of my arrow is there and there. So they're both facing to the right. Let's look at another problem. Might be a little more challenging. Negative 8, x minus 1, minus x is less than or equal to negative 28. I'm going to first distribute, so negative 8x plus 8